People love to hate server-driven approaches like LiveView, saying that it's not possible to make polished experiences without bailing out and involving front-end frameworks. But there are ways to write interactive applications without needing custom JavaScript. Phoenix comes with a module called LiveView JS that provides building blocks for these use cases, and they can be controlled entirely in Elixir code. In this video, I'm going to walk through every single LiveView JS command. I've broken them down into 6 families and added timestamps below, but each demo builds on the previous, so you probably want to watch them in order. My name is Christian, and I'm a polyglot staff engineer with a fondness for Elixir. All the code from this video can be found on GitHub with a link in the description. But first, I have to set some context. LiveView centers around a WebSocket-based model where a stateful backend sends diffs to the front end. It does this with a tiny JavaScript layer that you may not have ever paid attention to. By importing LiveSocket and connecting to the backend, we can build incredible server-pushed pages. But it's more than just pushing from the backend. When you add a PHX click attribute to a button on the page, this same package transforms the click into a message that can be interpreted by the server. In this case, when I click the button, the server knows to increment this counter. But it turns out strings aren't the only things that can be added to the PHX attributes, and that's where JS commands come in. This exact same behavior can also be achieved with a js.push call, which the library knows how to interpret. The value of this will become more obvious as we start exploring. So, let's get to the first family of commands, the ones that control CSS classes. For an interaction to feel instant, we need to change things on the screen in as little time as possible. In some cases, a server round trip is just too long. This is why the CSS commands are valuable. The most simple example I could think of is this button. When I click it, the green background class is toggled on and off. By default, JS commands target the element that triggered the event, which in this case is the button itself. Nice and easy. Up next are the add class and remove class commands. When I click the make it bold button, the target element's text becomes bold through the addition of the font bold class. The make it normal button, on the other hand, executes the remove class command. Both of these are using the to option to reference the target text element by ID. Behind the scenes, LiveView JS uses document.querySelectorAll, so any selectors that are available there can be used here. It's probably a good time to show how these JS commands actually work. It's pretty simple. The function calls get serialized into a string that's held in the attribute. The library automatically picks these up and knows what to do with them. In the case of the first button, the add class command shows up with its attributes in an array. The same thing for the other button, just with the remove class. The JavaScript library is included in the Phoenix LiveView package, meaning that everything emitted by the Elixir code can be understood by the corresponding front end. Now, the final command in this family is a bit different. It's called transition, and it lets you temporarily apply a class and have it removed after a short time period, 200 milliseconds by default. Imagine you want items to bounce when they enter the page. By setting the PHX mounted attribute to a JS transition of the animate bounce class, it'll do just that. And if we want to change the duration, we can just set the time attribute on the function. It'll handle all of the heavy lifting. There are cases where you might want to orchestrate something a bit more complex, for example, fading an element in. To support this, the transition command also accepts a 3-element tuple that contains a transition class, a starting class, and an ending class. So if I want to fade some text in, I can set the transition to something like ease out duration 1000, from opacity 0 to opacity 100. And because I set the time to 1000, these classes will be present for the right duration. It's important to have the duration of your transition match the time attribute of the transition function, because these classes are going to be added to the elements and then removed after the transition is done. One reason I said the transition command is different is that its behavior is also duplicated in many other commands. It turns out animation is pretty common. The same strings and tuples can be passed to add class, remove class, and even toggle class through the transition option. These JS commands can be piped together like many other Elixir structures, each step building on the context from the previous. Let's take a look at this shopping cart. When I click the remove button, I don't get any feedback, and then the item just disappears a second later. This is obviously not a good experience. In the code, the button has a phx click attribute that is set to a push command. This pushes the remove item event, passing the item's ID as the value. But the event handler takes around a second to process, and the user doesn't get any feedback while they wait. So instead, let's pipe this push command into a transition command. This will cause the opacity of the row to fade out whenever the button is clicked while the server is processing the event. So now when I click the button, the row fades out and then it disappears. And I can do this on multiple elements at the same time. But I also noticed something. When I click this remove button, the button is still active. That's not quite right. So let's add the phx disable with attribute to change the text to removing and disable the button while the event's being processed. Now when I click the button, not only is the row faded out, but the button gets disabled and the text swaps to the word removing. Very nice. See, just because we're using JS commands doesn't mean we can't also use the other behavior that Phoenix HTML attributes enable. Anyway, the CSS class commands are really useful. When combined with other Phoenix LiveView features, it's possible to build something really responsive. Changing the color and size of elements is cool, but sometimes we just want items to show and hide in response to a user's action. For these use cases, look no further than the visibility family of commands. These commands, hide, show, and toggle, are pretty simple, and at first glance, it's hard to imagine why we even have these. After all, we could achieve something similar by adding and removing a hidden class if we're using Tailwind. But internally, these commands actually manipulate the display style attribute of the element instead of toggling a CSS class. To demonstrate these commands, I built another page. This time, product listings. Each item has a more info section that can be expanded to show the product's details. The most simple way to do this is to add the js.toggle command to the button, targeting the corresponding description element. Like many other JS commands, this one supports transitions. In this case, they take the form of in and out, each being executed in their respective conditions. I can add a nice 200 millisecond opacity animation, and the text will show up and disappear smoothly. But it's kind of weird to see the chevron icon not respond to the expansion. It's entirely possible to put huge chains of JS commands directly into a LiveView template. Like, if I had this toggle class of rotating the chevron 180 degrees, this technically would work, and now we've got that spinning icon. But this could get unwieldy pretty quickly. So instead, what we can do is we can extract this behavior into a function. So if instead I make this toggle description function have that behavior, then all I have to do is call it with product.id and get the same behavior. Putting commands into a function keeps your templates light and gives a meaningful name to the behavior, allowing you to construct a standard set of behavior that you might consistently apply across the entire app as it scales. Just like before, when I click the More Info button, the text shows up and the chevron rotates. You might also notice that this function takes in a JS struct, defaulting to an empty one. This allows the function to be chainable, just like all the rest of the JS commands, so that you're not limited to just this behavior in a phx handler. Like I mentioned before, the visibility commands work by altering the display attribute of their target elements. By default, when the toggle or show commands ensure an element is visible, they set display to block, which is fine for things like divs, but for an inline element like a span, this can cause a layout shift. For this reason, if I also toggle the more info and less info spans, I'll get some pretty weird behavior. Let's see what it looks like. If I click more info, now less info is on the next line and the chevron got centered. Clearly, something needs to change. And the Phoenix core team thought of this. By setting the display option to inline, I get to preserve my layout and toggle elements to build the experience that I'm looking for. Before we move on to the next family of commands, let's get a little wild. I'd like to make a button that collapses all of the open description toggles on the page. And it turns out this is pretty easy since the target selectors in JS commands are just query selectors. This hide all info button is actually already wired up to a function called hide all descriptions, which currently doesn't do anything. But if I add a few commands to it, in this case hide, show, and remove class, I can actually get the behavior I'm looking for. So if I expand the smartwatch and the wireless earbuds, and then click this hide all info, we'll see the text fade out, we'll see less info become more info, and the chevrons will all rotate. This works because all of the chevrons, descriptions, and info text have IDs with a known prefix. It's easy to write a query selector that matches that pattern. It's also possible to target elements based on CSS classes, element types, or other HTML attributes. Remember, these functions will target anything on the page that match these selectors. So now we can change the appearance of items, sometimes with animation, and we can show and hide things on the page, all without needing a server round trip, all written in pretty simple Elixir code. This next family of commands is a bit more UX than UI. Great experiences make it easy for a user to get their job done by minimizing the amount of effort it takes to perform any given action. One way to accomplish this is by being mindful of the page's focused element. For example, if you can save a user a click on a form field by automatically focusing it, you can let the user keep their hands on their keyboards and start typing. There's 4 commands that contribute to this type of experience: focus, focus first, push focus, and pop focus. That's a lot of focus. Let's take a look at a demo. I've got this page where if I click the name button, it'll end up focusing in on the name. It does this by running the js.focus command with a target element that has the ID of name. Now the form button uses js.focus first. It can be kind of tricky to find the right element to focus, especially when you're trying to make something that's reusable. In this case, I'll just select the form container. When I click the focus button, it'll just select whatever the first focusable element is. Now in this case, that happens to also be the name input. But if I were to rearrange this form and put dietary restrictions before the name, if I click this button, it'll select whatever comes first. And the name selector that uses focus on a specific input will still take us straight to the name. Now the other 2 commands in this family are push focus and pop focus. These commands let us create a stack of focused elements. I created a contrived example to show this behavior. When clicked, each button will call push focus before they send the focus to the next element. Push focus lets us bookmark the element and come back to it later. So when I click this 1 button, we'll run push focus and then set focus to 2. When I click on 2, we'll push focus of 2 and then move us over to 3. Now if I pop focus, it'll unwind the stack, in this case first going to 2 and then going back to 1. But like I said, this is kind of contrived. So let's see how this is actually used in some real code. The next version of Phoenix won't include a modal by default in its core components, but I'm going to walk through how the current modal works. This component is paired with 2 sets of JS commands in the show modal and hide modal functions. Showing the modal, unsurprisingly, presents the modal, the background, and the container. It then prevents scrolling on the body behind the modal by adding the overflow hidden class. Then it uses that focus first method to shift focus into the first interactive element of the modal. When it's time to hide the modal, we set hide to everything, we unwind that overflow hidden class, and we run pop focus. So what does that look like in a real page? Well, if I go to this list of animals and click the new animal button, then the name is automatically focused and I can just type something in. And if I hit escape, then everything closes. Same thing happens if I click outside or if I hit the X. But let's take a look at this new animal button. It's just a button that patches to the new route. Since it doesn't push focus, we don't automatically end up back in that button whenever we close the modal. If I were instead to add a phx click of js.pushFocus, then when I click on the new animal button and then I exit out of this form, my focus is back on this new animal. So I can hit enter, I can hit escape, back and forth. In fact, this is exactly how the edit button on the animal detail page works. So if I hit enter on this edit button and then escape, I'm back in that edit and can keep on going back and forth. It brings me back to the context that I was in before. So remember, pop focus does nothing without a stack of focused elements. Make sure to push if you want to pop. Otherwise, it's a no-op. It can be helpful in certain contexts where taking the user back to where they were, wherever that was, is valuable to you. Driving a user through pages is something that's existed since the early days of the web. Unsurprisingly, there's JS commands to assist with this in the navigation family, which includes the navigate and patch commands. The LiveView request cycle isn't the same as traditional web interactions, in that there's a distinction between changing views and changing parameters in the same view. If two pages are served by the same LiveView, a patch is possible. This causes the handle params function to be invoked, and a normal diff is sent to the browser, the same as what you would get whenever you click a button and increment a counter, for example. On the other hand, navigate causes a new LiveView to be mounted from scratch in the current WebSocket connection. If you want to change to completely different pages, for example, going from this list view to the detail view in this animals context, you might reach for js.navigate. The code that comes with the Phoenix Live generator uses JS Navigate when you click on a form row. Let's take a look at what happens over the WebSocket. When we perform this navigation, the browser sends an event and gets the entire page back. In total, this is 17 kilobytes of transfer. On the other hand, I'm using a patch command to navigate between an animal and its friend. In this case, if I scroll down to the animal's friend button and click on it, and look at what happens over the WebSocket, I say live patch to animal number 3, and I get back 900 bytes of data instead of 17,000 bytes. So this diff is less than 1 kilobyte, and it just says change these things on the page. Navigate and patch both have an optional argument called replace. When it's set to true, this value causes the browser to replace the current page in the history instead of creating a new history entry. It's false by default for a reason, but if you need it, know that it's there. It's most commonly used in situations where maybe you're sorting a table and you need to store that in a query parameter, and you want to use the handle params callback to control that data flow. But what we've used so far for navigation is actually a pet peeve of mine. As I mentioned, browsers have had navigation for a very long time, and the anchor tag is the native way to support navigation. It powers things like open in new tab. Users expect to see where a link will take them at the bottom left of their screen when they're hovering. But if I hover over this row, I don't get anything. I don't know that when I click this, I'm going to be taken to a different page. Contrast that with things that are actually links, like this edit button, which down at the bottom left corner shows that I will navigate to animals/1/edit. This is because this is actually a link. Well, if I go into the source code and take a look, this show button is actually using the link element, which internally is an HTML anchor tag that has navigate or patch set on it. These still get to navigate over the WebSocket, but we get all of the native goodness that come with anchors. So save the js.patch command for things that aren't navigation, but where you want the state to be held in the URL, maybe as a query parameter. And as for js.navigate, use cases that aren't actually anchor tags are few and far between. Using the right element for each action is one part of building semantically correct web applications. But there's another aspect that can be very important, making a page accessible through ARIA attributes. The next family of commands control the attributes on HTML elements. It turns out that the show and hide example from earlier isn't up to accessibility standards. Now, I'm far from an expert in accessible development. Unfortunately, it's not a very common skill set. I'm looking to be more inclusive in the work that I do, but if I miss something, please forgive me. Anyway, it's important to let the browser know that our button controls another section and describe whether the info block is expanded or not. So I'll go back to the code for this page and add the ARIA controls attribute. This says that the button controls the description area. And since it's collapsed by default, I'll set ARIA expanded to false. Now when I'm toggling the description, I'll also toggle the ARIA expanded attribute between true and false. This 3-tuple construction starts with the attribute name and then the values that we're toggling between. In other cases, a 2-element tuple can be used when an attribute should just be removed when toggled off, as may be the case when toggling the disabled property on a button. Now if I watch in DevTools as I expand the info section, I'll see that the ARIA expanded attribute follows whether this is visible or not. Screen readers and other accessibility tools now have a better understanding and can more accurately describe this page to the user. If we were to stop here, the attribute might get out of sync if the user clicks the Hide All Info button. because this isn't targeting the ARIA expanded. And now if I click more info, when it's expanded, it'll end up being false. This isn't okay. And that's where the set attribute command can come in. So over in hide all descriptions, I'll add a set attribute saying that the ARIA expanded value should be set to false on all toggles when we hide the descriptions. Just like that, when I click hide all info, ARIA expanded goes back to false and everything is synchronized. Finally, there is a remove attribute command, and naturally it does exactly what it says. It removes an attribute from an HTML element. Well, I'm not using it in the code here. This is what it looks like. And that brings us to the last family of JS commands. You made it. Congratulations. This group is a collection of 3 actions, 2 of which have quietly been included in other parts of this video. The push command that was introduced at the beginning of the video is the first one I'd like to highlight. As you've seen, it lets us send a message to the server as part of a JS command chain. Recall the class demo where we walked through this optimistic UI for a shopping cart. At the time, we were focused on the transition command that let us smoothly fade the opacity down on the item while we waited for the server. But the beginning of this chain was the js.push command. When it runs, the LiveView JS runtime grabs any data attributes on the element, merges them with the optional value argument, and then sends it up to the server. There's one more option that I'd like to highlight here: loading. This is defined as a selector to apply Phoenix loading classes to. Let's say that while an item is being removed from the cart, we want to make sure that the total element is crossed out. To get this behavior, let's add the loading option to the push command, specifying the total ID, and then down in the total element, we can add phx click loading line through. This variation is supported by default in the Phoenix generated Tailwind configuration. So now, when a push is being processed, we will temporarily strike through the total until it's complete. And I can do this on multiple elements. The class won't be removed until everybody is settled. The other command in this family that you may have seen was actually hiding a bit better. The exec command was used in the modal, but I didn't draw attention to it. Exec lets us directly execute JS commands that are located on a certain attribute of an element. It turns out that in the modal, if we click outside of it on that background area, js.exec is used to execute the data cancel attribute from the modal's main element. Data cancel is yet another JS exec which runs phx remove. By default, it ends up reading from the same element and runs hide modal with that ID. The first element here, on cancel, is actually an argument that could be a JS command because js.exec can be chained. So again, let's take a look at when we hit the escape key. We run js.exec to run the data cancel attribute. Data cancel might run that on cancel JS stuff. That might be a transition. It might be another one of these execs. And then it'll run phx remove, which is the hide modal function. And the hide modal function ends up composing all of these different actions. So exec can be used to orchestrate outcomes across multiple elements, playing along nicely with other JS command chains that might be found in other contexts, whether those contexts are arguments or other elements. I know that can get kind of complicated, but if you just walk through it step by step, I promise it can make sense. Now finally, there's dispatch. I saved this one for last on purpose because it's an escape hatch. This command sends an event to an element on the page. In its simplest form, it could let us click things automatically. If I were to add it to a demo, I could make a button click another one by setting the hover to do a JS dispatch and send a click to another element. But the real reason to use dispatch is to add new things to your app that aren't natively supported in LiveView JS. The classic example is adding a clipboard copy action. Over in app.js, if I add a listener for the copy to clipboard event, this is an event that I just made up right now, then I can use the js.dispatch to say copy to clipboard targeting that target text. So if I click this button and then paste, I'll see that I've got this lorem ipsum text that came from this target text element. JS interoperability in Phoenix takes many forms, and dispatch is the most basic entry point. For more advanced use cases, check out hooks, something I covered in another video. So there you have it, a tour of every LiveView JS command. We've covered a lot of ground, from tweaking CSS classes and toggling visibility to managing focus, navigating pages, and even dispatching custom events. To recap, LiveView JS commands bring smooth, instant interactivity to your Phoenix apps without having to write much JavaScript. These commands are incredibly composable. You can chain them together, extract them into reusable functions, and create complex behaviors with just a few lines of Elixir. And best of all, they come built in with Phoenix. No extra packages or dependencies necessary. The next time you feel like you have to abandon Elixir, just know there's more options than an all JavaScript rewrite. If you found this video helpful, please show your support by liking, subscribing, and sharing with others. And hey, if you're using LiveView in an interesting way, let me know in the comments below. I'd love to see what you're building. This has been Code and Stuff. Thanks for watching.